Ready to take some notes? Okay. Are you guys ready to review? I know you guys are so excited. All right, let's start classifying real numbers. So the date is the 9th. Everything we do is pretty much organized into these into these notes. Sorry, there's a little bit of a delay. That's frustrating. Okay. So let's go ahead and get started. So let's classify some numbers. Put that down. How to classify real numbers. So this is the number grid about how to classify certain types of numbers. So what should go up top if we're classifying real numbers? Rational is on there. You're close. What goes at the very top, though? These numbers are called what kind of numbers? We're classifying real numbers. So all of these numbers are real. So up here, I'm going to write real numbers. We will get into complex and imaginary numbers on the next page, on page 2. Haley, is it not working for you? Is that popping up at all? Okay. Can you see what I'm writing? Okay. What I'll do is I'm recording this, so I will send you a PDF of this, and you'll just have to go back and write it. I'm sorry. Okay. Does anybody know the symbol for real numbers? It's what? It's a letter. Yes, it is an R with an extra line. Good job, Destiny. It looks like this. Okay. R with an extra line. That is real numbers. Okay. How are the real numbers broken up? So what's the subgroup of real? Integer is on there, but before integer, there's something else. Imaginary is kind of on its own thing. So all these numbers are real. Whole numbers down towards the bottom. Nope. So real numbers are broken into 2 categories. I'll give you a hint. One of them is like 20, and another example of one of them is pi. Rational and irrational. Good. So rational goes on the left. Irrational goes on the right. What's the symbol for rational? Nope. I honestly don't know why these letters correspond to some of these. Rational is Q with a line through it like that. Okay. Anybody know irrational? It's been a long time. This is like algebra 1, like the first thing you do your freshman year. Irrational is a P. I don't know why they chose these letters. I'm sorry. What are some examples of rational numbers? It's okay. What? Yeah, random numbers. 1 is, whole numbers. So I can put the number 1. That's rational. Can I have decimals if they're rational? Yes, if the decimal ends or if it repeats, it's rational. So for example, you can have the decimal 0.333 with a repeat bar. If the fraction repeats, it is rational. If the fraction just ends and terminates, such as negative 3.5. That fraction, or that decimal ends, so it is rational. You can also have fractions, such as 20 over 7. So that is a fraction, so that makes it rational. So the ways that you know that a number is rational, first is that it is a decimal. Okay, it's a decimal with repeating. Or termination. So it's going to end, or it's just going to repeat itself, like 3.7373737. Now your calculator will round up at the end. So if you see something like 0.777777 and at the end it puts an 8, it's just because your calculator rounds it up. Okay. The last important thing is that it can be written as a fraction. What's an irrational number? Pi is irrational. The ACT loves to use pi because remember, the whole ACT, if you guys did not know this, the math can be done without a calculator, all of it. It's designed to be taken in 60 minutes, making a perfect score without a calculator. Okay? So if your calculator dies during the ACT, there's still hope. Okay? You can do them all. That's why the ACT likes to repeat some numbers. So they're going to use pi a lot. They also like these other common irrationals, which are the square root of 2 and the square root of 3. Those are irrational because when you square root them, their decimals go on forever and they never repeat, ever. Pi is just infinite. It has never repeated, okay? The square root of 3, the square root of 2, they go on forever. So irrational numbers, those are decimals that have no end or never repeat. So the square root of 2 will go on forever and it will never repeat. So it is always irrational. So if you see the square root of 2, start thinking irrational numbers, pi and the square root of 3. The ACT loves them. Okay? And then last, it cannot be written as a fraction. Okay. So that's kind of the end for irrational. Either you're rational or you're irrational. Once you hit irrational, there's no other subcategory. It just kind of stops. However, we can subcategorize rational even further. So what is the next subcategory of rational? It is integers. Good job. It's integers. What's the symbol for integer? It's a Z. With that weird line through it. What are some examples of integers? Yep, they can be negative. What else? Which one? 2 works. What's another? You have infinitely many choices to pick from. 6. Literally, they're just numbers that are not decimals. That's what an integer is. So we refer to integers as number line numbers. When you draw a number line, you go all the way infinity to the negative, positive infinity, and 0 in the middle. So integers have no decimals. Okay. Basically, they are negative. Then they go to 0, and then they go to positive. The ACT likes to test your knowledge of numbers and number classifications using number lines. So if I wanted to plot the integers on this number line, how would I plot the integers? I got -4, -3, -2, -1, 0, 1, 2, 3. How could I plot the integers on this number line? Dot where? Okay. So are all of the numbers on the number line integers that are shown? Okay, they are. So what I would do is I can put circles at each of the numbers. So the ACT is going to say, okay, based on this picture, what number classification do you have? So it'll say all of these numbers on this number line are blank. And then your multiple choice answers would be irrational, imaginary, whole numbers, integers. Like it will test your knowledge of numbers using a number line. So integers have no decimals. They can be positive, negative, or 0. So if you see this question, your answer is integers. Okay? So ACT likes to make easy concepts difficult by putting all of the information on a number line and showing it to you in a different way instead of listing it out. What's the subcategory for integer? Whole numbers are next. Zoom out here. So whole numbers go here. What's the symbol for whole numbers? This is one of the only ones that makes sense. It's a W. It's one of the only ones that actually, that and real numbers are the only ones that make sense. What's an example of a whole number? 0 is the first whole number. Then where do they go from here? Up. Can I put decimals? No. So 0, I could put 150. That's a whole number. 25, that's another example. Whole numbers, basically, as you move down this chart, we start removing things. So the last group of numbers, they couldn't be negative, or they could be negative, but no decimals. Now we have whole numbers. They can't be decimals, and they also can't be negative. So as you move down the chart, we kind of take away a classification specification. So whole number, those are no decimals. Okay. They start at 0, and then they go positive. So how would I draw on my number line my whole numbers? Yep, start at 0 and go up. So on the ACT, you got a question like this. It's got solid circles at 0, 1, 2, 3, 4. It's going to ask you what numbers are shown. Those are whole numbers. I put this question on your first test, so pay attention to the number lines. They're really easy questions. It's just you overcomplicate them because you're not used to seeing whole numbers on number lines. Okay. What's the last subgroup? Reals up top. These are referred to as counting numbers. Natural. There we go. And this one is also making sense. This is an N. The natural numbers is an N. Natural numbers are referred to as counting numbers because if we say count to 10, you don't start at 0. You don't go 0, 1, 2, 3, 4. We start at 1. So natural numbers start at 1 and continue. They don't have to be consecutive. 4,802 is a natural number. We just can't start at 0. So these are referred to as counting numbers because if we tell you or ask to count to 10, you don't start at 0, you start at 1. So counting numbers, no decimals, no negatives. No decimals, no negatives, positive numbers only. only positive. So to fill in your number line with natural numbers, where do we start? 1. So here, continue. It's important to not let the ACT trick you. Okay? It's going to show you numbers on number lines. They're still numbers. They're just not listed for you. They're written on a number line. Same thing. It's just a different way to make a very easy question hard. Their goal is to not give you free money. And our goal is to get you free money. Okay. All right. Let's talk through just some math, adding and subtracting, multiplying, things like that. So right here, it says operations involving rational and irrational numbers. The ACT expects you to be able to do these calculations in your head. They're possible because the whole test has to be done without a calculator. So the first one is a rational number, and if you would like to use the letter R, you can, if you're used to the symbols. So if I have a rational number and I add it to another rational number, a rational number plus a rational number, what is the outcome? What kind of number? A rational number. So a rational plus a rational is rational. For example, if I do 1 plus 1, that is 2. That's a rational number. So it doesn't matter what number you pick. If they're both rational and you add them together, the outcome is also rational. What about a rational times a rational? What's the outcome here? It's a rational number as well. 1 times 5 is 5. It's not going to magically become this random repeating decimal or infinite decimal that never repeats. So it is rational. Next one is an irrational. Again, you can use the symbol if you want, plus an irrational. What kind of outcome do you have with irrational plus irrational? Irrational. If you add a decimal that never ends and never repeats to another decimal that never ends and never repeats, you're not going to magically get 2. Or like a whole number or a rational number. Once you throw irrational into the mix, you don't get back to rational unless they cancel out. Now, there are times when the problem does happen like that. But for the most part, if you're just adding 2 irrationals together, they're going to stay irrational. The last one is rational times irrational. What outcome is that one? Irrational times irrational. Which one? That one's going to be irrational. So when you start throwing irrational numbers in there, it's hard to go back to where you started with a nice clean number. That's why we use a symbol for pi, and we don't write pi out because it never ends. So another way that the ACT makes your life difficult is they purposefully take numbers away from you. Instead of giving you a problem where it says 2 plus 2 equals what? We all know it's 4. The ACT says m and n are even numbers. When you add n plus m, what do you get? An even number. But they take away the number to freak you out. But it's nothing that you can't do. It's not like it's impossible if you know what numbers are and what they represent. So to end, let's go ahead and do 1, 2, 3, 4, and 5. You can use your calculator on your phone. I haven't sanitized them or anything. So if you need to know what the square root of 21 is, you can. So classify 1 through 5 as many ways as you can.